Hi, my name is José Joaquín Atria, and I'm going to be giving a talk about Perl game development, or something. So a little bit of housekeeping. The slides for this are on that URL, and the GitLab link in the slide that has the code for the project that I've been working on. I would like to say that the links for this are in the talk page, but I haven't been able to edit them on time, so I need to talk to the conference organizers to update them, but they will be there soon, hopefully. So a little bit about me. I'm a developer at CV Library here in London, and we're hiring. Surprise, surprise. So if you want a reason to stay in London, if you're not currently, then come talk to us. Also, a little bit about me. I'm actually not a game developer, so I might not be the best person to be giving this talk. So why am I giving it then? Because you seldom see these talks, and I'm a firm believer that you should give the talks that you'd like to see. So this is me telling you to make more talks like this, please. And why games? So I think that this should answer itself, really. The first thing that I did when I started using computers was play video games. And the first thing I wanted to do when I started being able to write code was to write video games. And I still do both of them. So for me, this is a pretty obvious thing to try to do. More practically speaking, video games are really attractive to newcomers. Everybody wants to write a video game, at least in my experience. And writing them is actually really interesting. So they raise interesting problems, and they force you to have to solve them in smart ways. You can't take too long. You can't be too ugly about it. At least it can't look too ugly. So for me, games are interesting both for beginners and more experienced developers. So a little bit of history. In February, I decided that I wanted to try and clone a game that I liked. And I had a little bit of experience using Pico 8 and Love, which are Lua-based libraries. So I thought, hey, why not try it in Perl 5 this time? I will be only talking about Perl 5. There's a lot of stuff that is interesting about Raku or Perl 6. And it looks like a lot of that would be very useful for game development, but I just wish there were more time to do all these things. So a little bit of a background check got me thinking, what other video games have been made with Perl 5? And it turns out that most successful examples are browser-based games. So one example of this is Nation States, which I highly recommend. It's a browser-based nation simulation game. It's spawned off of a political satire book. And it's active since 2002. It has like 150,000 nations. These are active nations that are being updated constantly, solving issues and basically playing the game. So it has a still active, thriving community. So this is my nation. Apparently, my economy is basket case, but we're a struggling nation, but we're moving along. There's one thing about nation states that is actually quite fun is that they organize the nations in sort of United Nations, and they actually received a cease and desist from the United Nations itself, saying that they didn't want to be associated with nation states, so they had to change the name. Another example of this is Tao Station, which is much more recent. It's a sci-fi MMORPG, and it's new and it's very exciting. There's a lot of tech that is being developed for this, and Ovid has been giving a lot of talks and releasing some of the modules that have come out from this, and some of them are actually really interesting. So I would highly recommend you to take a look. It does require more commitment to play than nation states, so that's probably why my character still looks very much like this. But it's a very beautiful game too, so check it out. And there's actually been a lot of other games like this. Perl 5 browser-based multiplayer games. And it's not surprising that this is the case. When I think about what would be difficult when releasing a Perl 5 game, I can think of deployment or installation in the person who's going to play it, in the computer of the person who's going to play it, that being an issue, and keeping the code secret so that exploits are harder to find. But with a browser, you don't have any of those problems. So this is a working, usable model, which is not what I'm going to use. So what's more relevant to my case, which is locally running a video game? Well, Frozen Bubble is the obvious example. I actually played Frozen Bubble years before I knew it was written in Perl, and I was really surprised when I actually found out that it was. This is a comment in the actual source code. It was developed between 2001 and 2008, and it's very widely distributed, several 100,000 downloads. You can actually install it just from the app, and it just works. But the code is actually quite low-level SDL code. It uses Perl 5, but I don't think it's necessarily a good example to follow for new games. A more recent example that I think is worth looking at is Microidium by Christian Wald, which is a clone of Luft routers. It hasn't been released yet, but I would recommend you take a look at it. It looks beautiful, and it runs really fast, too. So that proves that you can do it, and Perl 5 performance is not really that much of a concern, at least for this sort of thing. It uses SDL and OpenGL and PDL for number crunching and for rendering. And it uses a client-server architecture for multiplayer support based on the model used by tribes. So there's a lot of really good ideas in this code base. And installing it on my machine actually was not so difficult. So back to my game. I had to start searching for an engine because I didn't want to write everything from scratch. And it turns out that there's more than one way to do it. And searching around, I found several different Perl 5 game engines. So there's GameFrame, and March, and Arcus, and Oyster, and Avenger. And all of these have not been finished. So I ended up using SDLX app, which is the best, not quite a game engine that I could find. It's being developed by a group of people that collectively use the handle Perl Game Dev, so props to them. The good about it is that it's on CPAN, so you can actually use it. It's part of the SDL distribution, and it has a lot of convenience methods to use that basically mean that you don't need to touch SDL so directly. You still need to understand some of it, but it's not so demanding. And there's a lot of existing examples, a lot of apps that you can find on GitHub, a lot of like little tiny demos that have given me examples of everything that I've needed to do so far. And it's been updated relatively recently, which means that the people are still around, which is good. The not so good is that the interface can get a bit clunky, and the documentation seems like it hasn't decided whether it wants to document SDLX app or SDL itself. So sometimes it's hard to find information about how something needs to be used. But the examples, like I mentioned, plug that in. And some of the things were implemented before there were more modern approaches. So your expectations might not be fully met sometimes. But I think that this will work, and it has worked for me. So the plan for me was to clone a game called Invisible Ink, which is a turn-based, top-down, 2D stealth tactic game. It's a little buzzwords. For the code layout, so there's a lot of information in this slide. This slide could be a talk in itself. But basically, I'm using a CPAN file to manage my dependencies. And I'm using a lot of modules that I'm developing sort of on the side that haven't been released to CPAN. So I'm using vendor modules that get installed by Carton. And for those, I'm using a regular release pattern whenever possible, so that I keep track of what version of the code I'm using. That has made my life significantly easier. And I'm trying to keep the engine code separate from the game code, which has also served to simplify some things. So this is the 10,000 feet a view of what the game would look like, or the structure of the code would look like. So there's a top game object or class, and then that you have stages that you plug into it, and the stages have entities, so like the heroes and the enemies and whatnot. And you can plug the stage in and out to change, say, from where you're in a menu or you go into another level. And the game knows to pipe the events into that stage, which means that I can change the event source into something else. I'm currently using SDL, but I could be using term Kaka, for instance, or something like that. And what motivated all of this was me finding this book called Game Programming Patterns, written by Robert Nystrom. The book is free online, so you should definitely go check it out. It's a jewel, and it goes through different programming patterns that he's found that are useful. And I'm going to be talking specifically about 3: the flyweight pattern, the observer pattern, and the component pattern, and showing a little bit how these look in Perl 5. So the flyweight pattern is basically splitting an object into what is shared among all of the instances of that object, which is called the intrinsic state. And then the extrinsic state would be instance specific. So to put it in a concrete example, the book talks about a game grid with cells. So the cells would have different terrain types, for instance, and different properties. So say a mountain would be impassable. All mountains would be impassable, but maybe some mountains have gold mines or something. And it turns out my map will have grids. They won't have terrains, but they will have sprites and common behaviors. And I've used a XML-based format called TMX to define them. There's actually a CPAN library for that that I've sort of forked and started using myself, which gives an example of how this would look. So you would have a grid class that would have a tile set, which is basically a set of tiles, and then different layers that would reference those tiles. So any specific information for that cell would live on the cell, but the shared behaviors would live on the tile. So it would look a little bit like this. You would have an array of tiles in a tile set, and then the cell would have a tile that it can reference, and any specific information would live as attributes on it. And if you use the handles option, you can actually make the relationship invisible. The users of the cell class never need to know that they're talking actually to a tile. So this actually works out really well. And it means that we don't have to duplicate information when we don't need it, and we can keep it shared where it's supposed to be. And you can use a subset of the TMX format to even use that for content that is generated procedurally. So that's really useful. Another pattern is the observer pattern, which is basically that you can announce an event and do not care about who gets notified. And likewise, on CPAN, there's a lot of solutions for this. If you search for emitter, you get about 60 results. My current favorite is one called beam emitter, which you can use like most of the other emitters to just emit events and sets of arguments, just like a plain list. But it actually prefers to use event objects. And the killer feature that this allows is that the events can be stopped, like they do in, say, JavaScript with the prevent default. So this is how it would look. So you would have an emitter that implements that role, and then you just subscribe a sub to a particular event. And then in that sub, you do not get a self. The event knows who emitted it, so you don't actually need a self. And you can stop that conditionally, and then basically what that means is that any other listeners to this event, they never get it. Basically the loop bails out. And when you emit the event in the outer code, you actually get the object, and you can examine the state of that object, of that event object, after it's gone through all of the listeners. And another interesting feature is that when you subscribe to an event, you get back a code reference that you can call to unsubscribe, which means that you don't actually have to pass references into the caller to unsubscribe, which prevents some memory leaks or the risk of memory leaks. So this is a more realistic example. This is a simplified version of the function I use to change the stage in the game. So you get the game itself and a stage And then you subscribe the stage's listeners, which don't show in here, but they look like that, onto the emitter, the event source that the game is using. And then you basically collect all the unsubscribers into like an internal reference. And at the end, you unsubscribe if it exists. So basically what the effect is, when you try to load a stage, it will unsubscribe all the listeners from the previous stage and then replace it with a new one that knows to listen from the event source. And the benefit is that it allows me to keep this decoupling between the game and the stage. And because of being able to stop an event in a listener, I can control the event's lifespan. So if a key event, for instance, has been processed by an entity, I know that no one else needs to care about it. I would like the ability to be able to forward events so that I could have tree structures of entities that I can plug in and out of a stage, but I don't think that Beam Emitter supports that just now. The last pattern that I would like to talk about is the component, which allows entities to span multiple decoupled domains. This is what it sounds like in the book. There's an entity systems wiki that defines them as a container into which components can be added, and then a component as a class of objects through which behaviors, looks, and data can be added to an entity. None of this made sense the first time I read it, but basically, I think they're talking about roles. And the good thing is that Perl 5 has superb support for roles. So you can actually define a class at compile time that will slurp in these units of behavior, or you can do it at runtime too, which means that you can actually read these, the definitions for these classes from a config file, which is mentioned specifically as a benefit of the component it's mentioned in the game programming patterns book as specifically something that you might want to do to separate the behavior of the game from the data, so that you can collaborate with people that are not programmers who can help you contribute to the game. So to close, can you write games in Perl 5? Absolutely, but I would definitely wish it was easier to get started. I was talking before the talk about this. Somebody was asking me whether they should stop using C# and switch to Perl 5 for Perl game development, and I was like, not quite yet, I think. But you know, Godot, which is like a free version of Unity, has its own language that is not Perl, but it exposes an API that you can write bindings to, and you can write bindings in a bunch of different languages, and maybe one of them will be Perl. So maybe my answer to the question that I got before this talk will change in a couple of years. So what are some things that could help? Having a modern documented game engine, something like Avenger, for instance. Avenger is, I think, the best, the one that comes closest, which is an attempt by the people who wrote SDL at reimagining the interface behind the SDLX app, or maybe something new. I would also like to see more examples of finished games, not just projects that ended up being in GitHub somewhere. And community participation and events for visibility. There was actually some of this a couple of, almost a decade ago actually. There was an SDL Perl game contest, the idea was to submit a game for 1 game per week during a month. And there were 16 submissions, and you can actually see them, you can play them. I think it actually turned out really well, and we should do it again. But there are some unsolved problems, I think, which go back to my initial slide about why browser games work. How do we distribute it, and is performance really a problem? And how do we make money out of it? I have no answers for these questions. Thank you. Yeah, they talked about it at the Perl conference in Riga. It looked really interesting. I also don't know if it's an answer to the questions, but
so it's about 3 or 4 times slower than normal Perl, but it's transpiled to JavaScript, and you can run your Perl code inside of the browser.
yeah, and you can actually sort of ship it with your own modules too, I think.
Yeah.
I've never tried it, but maybe.
Any more questions? No? Okay.
Thank you.